Hello folks, we are once again back with this next video of this exercise 7.6 which we were doing last time. We are continuing with that. Now here we have this problem number 7 which we are doing the inverse trigonometric function for the first time over here. We have got x times sine inverse x. Let's right away find out what is u and v and get across doing the integration. So here this is the inverse trigonometric function and this is the algebraic function. According to our ILATE, we can have, let's check what is the u for us. Inverse comes first, so that is sine inverse x is your u, and algebraic is coming next, so that is our v. So right away let's go in for du over dx, which is the derivative, and we know the derivative of sine inverse x is 1 over root of 1 minus x squared. Let's find out the integral of v dx, which is x square over 2. Now having got this, let's go in for the integral, which tells the formula u integration v dx minus du over dx integral v dx the whole dx. And let's quickly substitute and see what comes. U for us is sine inverse x, and v we have got it as x squared over 2 minus du over dx for us, it's 1 over root of 1 minus x squared, and integral v dx for us, it's x squared over 2 dx. Now this is okay and solved, but this is not so good. You have to do further solving there. So let's continue with the solving, and it says that it is x squared sine inverse x over 2 minus, you can have the half out, and then you have x squared over root of 1 minus x squared. We'll do one thing for our convenience. Let's call this as I1. Work it out and plant it back over here. So let's call this as equation 1, and then we'll get the equation 2 from I1, and then together we'll club and get the answer. So for I1, we have, let's call the I1 as integral of x squared over root of 1 minus x squared dx. Now why we say it is not so simple? Because you have a quadratic in the numerator and you have a quadratic in the denominator with the root sign. So that is sufficiently complicated. So let's see how we can do it. So we'll do one thing. In order to get this numerator denominator complex removed, let's get the denominator in the numerator by some sense. Okay, so it's as good as calling 1 minus 1 plus x squared. There's no harm. We can call it like that, over root of 1 minus x squared dx. But that's as good as saying integral of 1 over root of 1 minus x squared, take the minus out, 1 minus x squared dx. So that makes this integral of 1 over root of 1 minus x squared. We have separated this term. Now let's separate this term, integral of 1 minus x squared over root of 1 minus x squared dx. So it's the same term, root in the denominator and no root in the numerator. So it's like a over root a kind of a thing. So that can be simplified, and the simplification is root of 1 minus x squared dx. Now at this juncture, I will just like you to tell, we are doing this in the upcoming exercises, but right now I will give you the integral so that we can use it over here. There is a formula of integral of a squared minus x squared dx. It works as x over 2 root of a squared minus x squared plus x over 2 root of a squared minus x squared plus a squared over 2 sine inverse of x over a plus c. So this is what we are going to apply over here. That's it. So then everything is ready made. For us, I1 is going to be, therefore I1 is going to be, this we know, 1 above 1 over root of x squared minus a squared dx. We had learned that. So if it is root of x squared minus 1 over root of a squared minus x squared, it is sine inverse of x over a. So sine inverse a for us is 1, so it's just sine inverse x. And here now, because we are applying this formula, let's see what comes. X over 2 root of 1 minus x squared plus a is 1 for us here. So 1 over 2 sine inverse of x plus c. That's it. So now let's plant it back, 2 from 1 and 2. Let's have I1. I is, first term is x squared sine inverse x over 2, and let's take this I1. I1 is first sine inverse x minus x over 2 root of 1 minus x squared minus sine inverse x over 2 plus c. Now these are the broad terms. I can bring the sine inverse x together and club it and further restructure the terms. That's like one's own convenience. However you want to rearrange, you can rearrange. That's all for this. We have done the inverse trigonometric for the first time, and with this kind of complication we use this technique. It's after all a matter of technique, and this is how we get the thing. So this is the answer for this question. We have a similar question coming up next. That's also a question on inverse trigonometric. So with that video, let's meet with that problem. Let's meet in the next video. So thank you for now.